Hello everybody. I want to give you an example of a statement that you can prove via contradiction. So the statement is a familiar one. The square root of 2 is irrational. If you wanted to parse this in terms of a conditional statement, something of the form if-then, we could say if stuff is normal, then the square root of 2 is irrational. So in order to do a proof by contradiction, what we're going to do is assume the negation of the hypothesis. So we'll assume that, we'll assume the negation of the conclusion. We'll assume that the square root of 2 is rational. So it's of the form a over b, where here a and b are elements of the set of integers. And further, we're going to assume that a over b is in lowest terms. So if there are any factors, they've been removed that are common between a and b. Alright, so since the square root of 2 equals a over b, what I'm going to do is I'm going to square both sides. To obtain two equals a squared over b squared. And then I'll do a little cross multiplying to get 2b squared equals a squared. So this implies that a squared is even, and this implies that a is even. Okay, on the other hand, since a is even, that means that it's of the form 2k for some integer k. So that means we can rewrite square root of 2 equals a over b as the square root of 2 equals 2k over b. And again, what we're going to do is we're going to square both sides. When we square both sides, we'll see that 2 is equal to 4k squared over b squared. This can be rewritten to say 2b squared equals 4k squared. And dividing both sides by 2 yields b squared equals 2k squared. Well, this implies that b squared is even. So we're at b squared equals 2k squared. This implies that b squared is even, and therefore b must be even. So to recap, we know that the square root of 2 is equal to a over b, and we also know that A over B is in lowest terms. However, if this is all the case, we've shown that it follows that both A and B are both even. Well, this is what we call in the business a contradiction. We can't have both A over B be in lowest terms and A and B being even together. All right, so that means that we've proven that the square root of 2 can't equal A over B, or the square root of 2 is irrational. We assume it is rational, and we derive a contradiction. That little rectangle says, we're done with our proof.